应该是吧，不然它应该是空白的，不会有这个 Serena 的。是这样。录个点看看，让 Serena 先录个点。
Hey guys.
Hi.
Hey.
Fernando?
Yep.
Welcome.
How's it going?
Good. We'll just wait for a couple of minutes.
Are we on YouTube yet?
What is it?
Are we on YouTube yet?
I think so. Yes, we are.
Alex, that's a cool microphone you've got set up.
A cool microphone?
Yeah, for Alex. Like it's all red.
Yeah. It wasn't my choice. I wish I could turn that off, but it isn't possible. So, yeah.
Is it only red or can you change it to be like RGB?
There is a version of it where you can do that, but yeah, I didn't pick those.
Are you guys together right now?
No.
Oh. Shall we start now?
Yeah. Up to you.
Okay, let's just start. 大家好，我是 OneBlock 的 Serena。今天的 Substrate Saturday 第5期的活动由我来主持。那么今天我们主要是以英文为主。Hello everyone, welcome to the 5th episode of the Substrate Saturday. Today, besides our Chinese community, we also have friends joining us from the other side of the globe. So please allow me to give a brief introduction on this program, Parity, OneBlock, and myself. My name is Serena. I'm the community officer from OneBlock, and I'll be moderating today's session for you. A brief introduction on the program. Substrate Saturday is a program brought to you by OneBlock and Parity. It is meant to help developers to better understand the basics of Substrate framework and to get on board with the ecological building using Substrate as an underlying language for Polkadot. We will successfully hosted 4 episodes of the program already. For each episode, we'll invite speakers who are the experts in the field from different organizations to give speech on their takes of the Substrate tool. So moving forward a little bit about OneBlock. OneBlock is the first and the largest blockchain. Sorry. Okay, sorry. OneBlock is the first and the largest blockchain developer community in China. We provide full support for developers with their Substrate studies and further set off their career paths. So our mission is to first bring developers into the space and then to help them not only to grasp the basics of Substrate, but also to teach them how to use the Substrate as building blocks to apply to the ecosystem with practical uses. Now, in addition, OneBlock hosts Polkadot hackathons every season to attract top-notch developers to build and innovate for the prosperity of the ecosystem. As a Greater China technology resource integrator, we also partner with developers, communities, business elites, and key media who have business insights and experiences in the blockchain industry to provide educational events such as technology courses, news, distributions, AMAs, and offline events for the industry. So now with that being said, if you are interested, please follow us on Twitter, Instagram, and Discord to get firsthand news on Substrate development. Links will be posted in the check box on YouTube later. And you're very welcome to join us. So Parity is a core blockchain infrastructure company. They create an open source Creative Commons that will enable people to create a better institution through technology. They invent a Substrate tool which allows users to create custom blockchain effortless. They're also commissioned by Web3 Foundation to develop Polkadot network. So today, we're very honored to have some of the core developers who are in Central Europe from Parity to join us here today to share some of the Ink smart contract related topics. They are the ones who invented the Ink smart contract. Unfortunately, Michael, Andrew, and Robin, who are on our poster, are not able to join us today since they are on vacation. But we still have Hernando and Alex here to share with us. So for today's agenda, we'll have 3 parts. We'll first play a pre-recorded video by Hernando on Ink smart contract overview. And then Hernando will do a live demo to walk you through how to deploy a smart contract. Then we'll have a Q&A session to have Hernando answer some of the questions that we collected from the community and the audience. So in the end, he'll pick his top 5 favorite questions, and then we'll send out a prize from Polkadot to the question contributor. So now Hernando and Alex are both online. I see them both. So without further ado, let's get right into it. So hello, Hernando.
Yes, Serena.
Hi.
Yeah, thanks for having me. So I guess I'll do a little
pleasure.
So
pleasure.
I'm Hernando. I'm a developer here at Parity Technologies. Usually I'm actually based out of Toronto in Canada. So I'm just doing like a little bit of a stop here in Berlin. And yeah, I'm excited to, showcase what we've been working on at Ink. There's a lot of exciting developments in the last year or so, and there's a lot of cool stuff on our roadmap as well.
All right. And Alex, are you there?
Yeah, hi, I'm here.
Yeah.
Hi, everyone.
Go ahead and introduce yourself to everyone.
Yeah, sure. Hey, yeah, my name is Alex. I'm based in Berlin. I joined Parity roughly 1.5 years ago as core developer. And right from the beginning, I have been part of the smart contracts effort together with Hernando, Michi, Andrew. And more specifically, I'm working on what we call the palette contracts. So this is a part of Substrate, which then runs the Ink smart contracts. So I hope maybe if there are some questions in this department, I can bring some expertise to the table.
All right, thank you, Hernando and Alex, again for the intro. And now, let's take a look together, the most up-to-date Parity Ink smart contract overview. Now let's play the video.
An overview of Parity's smart contracting language called Ink. So a little bit about me before we start. So my name is Hernando. I'm a core developer here at Parity Technologies. And I started off my journey at Parity actually working on the Ethereum client. Since then, I've worked through a couple different projects. I now find myself as part of the smart contracting effort. So I don't work on this team alone. I work with a bunch of other people, and individually, we're not that exciting. It's when you put us together that we become unstoppable. So let me introduce you to the rest of the team. So we have Robin, Mihi, Andrew, Alex, and myself. And together, we make part of the core smart contracting team here at Parity. So let's get into it. What is Ink? So Ink is a Rust-based embedded domain-specific language used for writing WebAssembly smart contracts. And let's take a second to unpack that, because it was a lot. So embedded domain-specific language, what does this mean? For our purposes, we can think about this as Ink is a superset of Rust. So it is Rust plus a little something extra to help us write code. WebAssembly is a portable format for running programs. So you can think of it sort of like the JVM, right? Or Java bytecode. It is portable and you write once and execute everywhere. And then smart contracts are these autonomous blockchain applications that we run. So Ink is meant for this one specific use case. And here's what an Ink smart contract looks like. And if you're familiar with Rust at all, you'll notice that Ink is just Rust. The only thing that really differs are these Ink annotations that you see throughout. So the contract, constructor, and message tags. But other than that, it's just Rust. And this is something that I'll be talking about a lot throughout this presentation, because this is what gives Rust some of its superpowers, or sorry, Ink some of its superpowers. All right, let's talk about the tech stack. Let's start off with the Substrate node. So the Substrate node is split into two components, or two general areas. So we have the client, or the core components, which have things like the consensus, the networking, the transaction pool logic. We don't care about any of that. We care about what's called the runtime. And the runtime is really the business logic of your blockchain. And in the world of Substrate, we build runtimes from these building blocks called pallets. And each pallet has one specific purpose. So for example, we can have a pallet whose job is just to track assets. Another one that just deals with staking. And in our use case, a pallet just for smart contracts. So let's dig in. What's inside the smart contracting pallet? Our pallet provides what's called a host API. And this is just a bunch of entry points for your smart contract to be able to call things like storage, to do things like gas metering, so tracking how much compute is being used by the smart contract, to do things like state management. So taking a deposit whenever a new storage item is created and giving you back the deposit once it's cleaned. This helps mitigate things like state bloat, which we see on chains like Ethereum. So once we have our Ink smart contract written, how does this actually get used? Well, first, we need to compile it down to WebAssembly. And we can do this by hand using the Rust compiler, but we've also built this nice tool called Cargo Contract, which tunes a couple different knobs in the Rust compiler settings and produces some other output, which is helpful for UIs. But ultimately, all it does is create this WebAssembly blob that knows how to interface with the functions exposed by pallet contracts. So you can think of pallet contracts actually sort of like an operating system that provides syscalls. But instead of providing system calls for interacting with the file system or networking, it provides system calls for executing a smart contract or writing storage entries to a database or doing cryptographic operations. This, you remember that each pallet is part of a more general runtime. And in the world of Substrate, the runtime is also compiled to WebAssembly. So we have a WebAssembly blob running inside another WebAssembly blob. And the runtime WebAssembly blob gets run by the Substrate executor. And this is what actually goes ahead and runs stuff on your machine. All right, so we've got a little bit of background with smart contracts and runtime development. So let's talk about the differences and what use cases might be better for smart contracts or runtime development. So smart contracts can really be thought of as user-level applications running on a blockchain, whereas runtime development is your blockchain. It is the business logic on which your blockchain runs. And smart contracts are relatively simple compared to the complexities of runtime development. With runtime development, you need to be a lot more careful about what because you have a lot more knobs to tune. Smart contracts are also immutable. This means that, once you deploy something, you can't easily upgrade it. This is great for building trust-free applications where you really don't want code to change underneath you. Runtime development, on the other hand, does give you the ability to upgrade code. And this is nice, but it can also complicate the lives of downstream developers since your blockchain can change its logic entirely just, on a whim. As a developer, you also have to be very careful in performing upgrades because you can easily brick or stall your chain if you do these upgrades incorrectly. Smart contracts are also untrusted. So whenever you upload a contract, we assume that this code is malicious. So we need to, as the blockchain, protect ourselves from malicious code. And we do this through what's called gas metering. So ahead of time, we ask you to set a limit for how much compute you're willing to pay for. And once you hit that limit, we stop all computation and revert the transactions. Runtimes, on the other hand, have code that's trusted. This means that we will run until we finish whatever computation is. This also means that if you misprice how much an operation might take, you open your chain up to denial of service attacks. So in general, the key takeaway here is if you want a lot of flexibility, if you want a lot of performance, you want a lot of knobs to tune, you should go for runtime development. But you also open yourself up to more risk. So if you want to mitigate that risk, you should probably go with the smart contract model. All right, let's talk about the different virtual machines you can use to write smart contracts. So the one most of you are probably familiar with is the Ethereum virtual machine. And in the world of Substrate, you can actually target it using a palette we have, which is called Palette EVM. And what's great about using Palette EVM is that you get Ethereum ecosystem support out of the box. This means you can use things like MetaMask or any other developer tools that you've gotten used to over the last couple of years. The EVM is also purpose-built. So for example, it has 256-bit words, which is great for supporting cryptographic operations. And you also have gas metering built in. So again, you don't expose your chain to any sort of denial of service attacks. On the other hand, we can also target WebAssembly, and this is what Palette Contracts does. The great thing about being able to target WebAssembly is that we can use any language that compiles to WebAssembly. So this can include Rust, C++, JavaScript, Go, and any other language that you come up with which compiles to WebAssembly. Another great thing about this is that we can kind of piggyback on the mainstream adoption that WebAssembly is getting. There's a lot of financial and developer support coming from companies like Google, Mozilla, or Cloudflare. Likewise, projects like LLVM, which Rust uses as their compiler backend, also support WebAssembly by default. So out of the box, we're getting all these compiler improvements and optimizations without having to do it all ourselves. WebAssembly was also designed to be very efficient. So its bytecode kind of mimics native instruction sets, which means it can run very fast on modern processors. All right, so we've decided that targeting WebAssembly is probably better for us. Now we need to pick what smart contracting language to use. So we can use Ink, or we can actually use Solidity through some different tools and compilers. So we can compile Solidity down to WebAssembly. And why might you choose one over the other? So some reasons you might use Solidity are if you already have an existing Solidity code base. You can just plop it in to the compiler and get WebAssembly out, and life is good. You don't need to retrain developers. You don't need to spend money re-auditing stuff. You can just kind of get going. And this is great if you want a short time to market. However, using Ink comes with a lot of other advantages. The main one is that Ink is just Rust. This means you can use all the developer tooling that already exists for Rust. You don't need a custom IDE. You don't need a custom compiler. You can use all the tools you already know and love. You can have access to not all of Crates.io, but a good chunk of crates that support compiling down to WebAssembly. And you also get all the nice things of Rust, that it's fast, lightweight, memory safe, and fun to write. All right, so what's the current state of Ink? Right now, we're technically in a release candidate stage, but we are going to get out of this soon. even though it's a release candidate, we haven't had any major breaking changes in a long time. So even today, as an RC, I'm pretty confident that you can get started developing smart contracts and you won't need to rewrite everything from scratch tomorrow. We also want a playground for developers to deploy and play with smart contracts. So what we've done is we've recently deployed a smart contract parachain to Rococo. So this will be a playground for you developers to try deploying smart contracts, try breaking pallet contracts, and just seeing what's available. After we get some feedback and make improvements, because there are going to be problems and bugs, we are going to have a pre-production deployment to Kusama. And this is really to validate our assumptions on economics. So for things like state deposits, are we charging enough? Are we charging too much? We can't really know until we have some real world economics in there. And after we have a nice stable deployment on Kusama, we're then going to become a parachain on Polkadot. And that's going to be our real stable production release. All right, so if you're interested in learning more, where can you go? Really, the best place to go is GitHub. Everything I've talked about here today is open source. We're very active on there. So if you have any problems, open an issue. If you want to make improvements, open a PR. We're more than happy to help you. If you want to learn about how to actually write and deploy some of these contracts, there's a couple tutorials and links available. So go check them out. If you want to talk with us, the developers, we mainly hang out on Element. So you can find us there. We're more than happy to answer your questions. If you're not a big fan of Element, we also have that channel bridge to Discord, so you can join us there as well. And that's all I've got for you today. So I think the main takeaway here is that, yes, we're in a release candidate, we're pre-production, but this shouldn't stop you from playing with this stuff. It's really interesting and fun, and we're more than happy to help you with any concerns or questions that you have. So thanks a lot for listening. I hope you enjoyed this, and I hope you get around to playing with our stuff.
All right, that was a very clear and detailed introduction on Ink. Now I hope that you have a good understanding of what it does and how it works. So to continue, let me hand it over to Hernando for his demo. Hernando, you can take over whenever you're ready.
Yeah, cool. So we gave you a little intro on, the high level of Ink. And now what I want to do is go ahead and show you how to deploy contracts on some chains. Can you guys see my screen right now?
Yes, very clear.
It's the Ink. Just got to make sure I'm sharing the right screen. Yeah, you guys can see the Ink GitHub repo?
Yes.
All right, cool. So as I mentioned, this GitHub repo is really the main starting point for everything. Here you'll be able to see, the different chat channels we have, the different tooling that you'll need, the UI and the node that we're going to be using. So today, I guess to start, I'm going to walk you through how to build a contract, how to deploy it on a local chain, and then I'll also show you how to deploy on our Rococo test network deployment. So actually, even before that, maybe I should walk you guys through what an Ink contract looks like. So the contract that we're going to be deploying today is going to be an ERC20 contract, just because that's a good analog if you're coming from the Ethereum world. And as part of the Ink repository, we actually have this examples contract. If the font isn't big enough on my terminal, just let me know. I can make this all bigger. So we can take a look inside ERC20. So first, let me show you what's inside. We've got a bunch of different example contracts, from different ERC standards to some, like a multi-sig or even a DNS example. So definitely clone the repo and check out what's inside. 20. And so if you're familiar with Rust, again, you can see that ink is just Rust. The contract really revolves around the storage struct, which we annotate with this ink storage tag. And then the entry points to contracts are these messages. So messages are, the entry points that users are going to call the contract with. So if a user wants to query the total supply, they'll be able to do that. If they want to do a transfer, they can also do that. Again, we just annotate it with a message. Or, approvals are also a thing, but really messages are the entry point for users. We also provide things like events. So when a transfer happens, we want to emit a certain event saying, Hernando transferred some tokens to Alex. And again, it's a normal Rust struct, and all we have to do is annotate it with an ink event. Yeah, so I'm not going to walk through the contract too much, but I did just want to show you that ink is just Rust. So let's get out of here. So I'm going to be doing some of this development on a remote server. My laptop isn't beefy enough to run some of this stuff, especially once you start running Substrate nodes and Polkadot nodes. So it's nice to have a remote server somewhere to do this. I think it's also a little bit of an interesting workflow. I don't know if everybody, like in tutorials and stuff, they don't really show you this. So what I'm going to do is actually first, using this tool called Cargo Remote, I'm going to go ahead and check that the repo compiles. It'll also transfer the repo over to my server. I've ran the command previously, so it's really quick. And you can see that everything's here. And then let's go back and see what what ink says. So we need to install this cargo contract thing. Let's do that. And while that installs, let's go to the cargo contract repo and see what this thing is. So cargo contract is a CLI tool. And as I mentioned, all it really is a wrapper around the Rust compiler, and it helps us produce WebAssembly and metadata for UIs. So that looks installed. Now we can check the usage. So first, what we'll do actually is, instead of building the contract, if you're developing, what you'll do is you'll actually want to check your contract first. So checking just makes sure that the code kind of compiles, but it doesn't actually produce any machine code that can run. So it saves you a lot of time in development. Actually, let me cd into the examples and do this. Another thing you might note is that we have to use the nightly compiler. There's a couple issues related to WebAssembly that we haven't made it to stable Rust release yet, so we need to use nightly, but that shouldn't scare you from doing this anyways. Okay, so our contract checked, it's good, so we can actually go ahead and build the artifacts. I'm going to build in release mode just so we can get some nice compact contracts. If you were doing development, you might just want to do a debug build. And as you can see, we've got a couple different artifacts. What we're really interested in is this ERC20 contract file. This includes the WebAssembly code, as well as the metadata for things like the UI. So I'm going to pull this contract code from my remote server so I can have it locally. Next, what we need to do is we need to start a local node where we can deploy this stuff. And luckily for you guys, we have just the thing. So if you're familiar with Substrate development, you know about this node template project. And what it is, it's just like a standard substrate node. So what we've done is we've taken the standard substrate node and added the contracts palette to it, and that's it. And this is a good enough test bed for you guys to deploy contracts. So you can deploy it, or you can install it directly with Cargo. I'm not going to do that. I'm going to run it from source, and I'll show you how to do that. So I've cloned the repo, so I have it here. And what I'm going to do is, again, I'm going to run this on a remote server. My laptop can't handle this and streaming at the same time. Again, using this Cargo remote tool. Since I'm running on a remote server, I also need these flags like, unsafe RPC and unsafe WebSocket. But I think for local development, you probably won't need this. One other thing I need to do actually is port forward from my remote server to my local machine. I think if you use VS Code, they let you port forward in there like automatically, but I have to do it manually. We need to wait for this to build, so we'll give it a sec. Yeah, even with a beefy machine, this isn't instant. All right, well, that's building. I'll show you where we're going to go. So we're going to use Polkadot.js apps, and conveniently in the repo README, we can just click here, and it'll take us to the right place. See if it's built. Yeah, so it's built and started running. This should be forwarded, and yeah, we get blocks. Let me blow this up. Okay, so next in Polkadot.js apps, we actually have a dedicated smart contracts tab. So this is quite handy because from here we can go ahead and upload our contract. So you can see this is the example contract that I just built and pulled down. I'm going to be using Alice's development account to deploy this. And you can see that the UI already knows of all these messages or entry points into the contract. And it knows about this because of the metadata that was bundled alongside the code. Right now, we need to specify an endowment. Going forward, we're not going to need this. This had to do with some state rent experiments that we were trying out. The UIs haven't been updated to reflect that just yet. Right now, I'm just going to put 1,000, but we're not really using this. I should also give it an initial supply. Cool. So we see that everything was successful. We have an ERC20 contract. Let's transfer some funds. So I'm going to get Alice to transfer some funds to Bob. We'll do 234. Here you can see that the UI can estimate how much gas you need for this call. We can also set it ourselves, but the UI is pretty clever. We'll just let it do its thing. Cool. So we did a transfer. Let's check the balance of Bob. And you can see that it's 234 units of our testnet or of our ERC20 token. So everything's good. If you then want to take your deployment to the next level, you can try launching on our Rococo test network. And this is slightly more complicated, but it's not that scary either. We have a lot of instructions in the README. So the starting point here is this Parity Tech Canvas repo. And here we have instructions on how to get started with the deployment. So let me first walk you through the steps that we need. So in order to deploy a smart contract on Canvas, we use the Rococo native token as our currency. This means that we need to get some tokens for Rococo and then send them to our parachain. And how we do this is first we'll go to the faucet on Element, request some Rococo tokens, and then teleport them over using XCM. So let me show you how to use the faucet. One sec. So this is what the faucet channel looks like on Riot. And all you have to do is, I have a test account here, and you can just say drip, you put your account address, you click enter, and then the bot will do its thing and send you some tokens. So let's give it a sec. While we do that, let me pull up the account tab for Rococo. Okay, so we can see that the bot has sent me 100 rocks, so we're good there. And yeah, so I already had some Rococo tokens, but it sent me some more. Put this away. So next, what we have to do, and again, this is all in the README, so I'm just going to follow what it says here. What we need to do then is go to this developer extrinsics tab. We'll go down to palette XCM, choose teleport assets. For our destination, we're going to put, it's a parachain with a chain ID of 1002. So that's the current Canvas parachain ID. For the beneficiary, it's going to be an account on parachain 1002. So it's an account ID 32. I have an account here. Going to transfer assets. We need to specify the assets to transfer. So we can either transfer fungible assets or non-fungible assets. In our case, it's going to be fungible. It's just the native token of Rococo. We're going to need to specify how many of these fungible assets we want. If I put one here, this is going to send one plank, so one base unit of Rococo tokens, which is not what we want. What we want is one whole token. So on Polkadot, this is 12 zeros. So this will send one token. The fee asset item, we're going to leave it 0. So it's going to indicate the native token of that chain. And let's send it over and hope for the best. One sec, I got to sign the transaction. Okay, cool. So it got sent correctly. If you noticed, before my balance used to be 50 rocks. Now it's 51. So we have tokens on Rococo that we can use to deploy our contract. So let's go ahead and do that. Again, we can go to this developer tab, go to contracts, upload and deploy code. We can use the same bundle, open this up. It already knows about all the messages. We'll set an endowment again, some initial supply, deploy. This is going to take a little longer to deploy. So parachain blocks are 12 seconds instead of 6 seconds as on the relay chain. There's a couple of extra things that have to happen behind the scenes. So yeah, we'll just let that sit for a sec. But you can see for like, once you get onto the Canvas parachain, it's the exact same thing as running a local node. Instantiate with code transfer failed. Live demos. We'll try again. I'm going to set a higher endowment, maybe. Max gas.
Yeah, I think what the issue might have been is that you the unit was set to rock, so you're actually sending 1,000 rocks and not 1,000 planks, and you don't have that amount of money.
Maybe it's it's a good point. All right, last try.
Check the unit on the endowment. Yeah, it's rock.
Oh yeah. All right. Yeah, I'm just used to having like millions of tokens on the developer account. Hooray, Alex saved the day. And again, we can transfer and do all the other stuff. So yeah, that's how you build and deploy contracts on a local node or on a parachain. So I guess let's jump to the questions now.
All right. Thank you, Hernando, for the detailed walkthrough. Yeah, now let's get into our Q&A session. So first, we would like to address the questions that we pre-collected from the community, and after that, we'll get to the audience if the time is allowed to have your answer, a question answered by Hernando and Alex. So, so if you have a question. For the audience, if you have questions, just write it down on the side of the chat box, and I'll go through in the order. So Hernando, for the first question, can you please share the high-level launch plan of Ink smart contracts, and how and when will you deploy them to production? For example, Kusama and Polkadot.
Yeah, okay, so I think I covered that in the last bit of the presentation. One thing I do want to note on here is that there's no launch plan for Ink smart contracts per se. Really, what needs to happen is that chains need to include the contracts palette, and then that's what enables them to write smart contracts in Ink or any other language that compiles to WebAssembly. So for us, we're putting palette contracts in our Canvas parachain, and then proposing it for deployment on all these other networks.
All right. So the second question: what's the roadmap of Ink's future development after the production release? This question is from Yuanjing Chen, from Patrick. Go ahead, Fernando.
Yeah, so ink right now is pretty stable, but going forward, something that we want to work on is modularity. So we want to make the developer story around having composable contracts and contracts across different files and crates, just make that a little better. Yeah, because the core language itself is pretty stable and pretty good from our point of view. We also want to work on the developer experience, so tooling and just making it easier to write and debug contracts.
Okay. So the third question, Solidity currently uses interface to define contract standards. Ink seems to use trait definition to define contract interfaces. Will there be changes to Ink abstraction to use more Rust features for contract standards?
No, there's no need to change it because it's our idiomatic Rust. And that's exactly how we would want to define standards. We want standards to be defined in terms of traits, and then we just want contract implementers to implement those traits as they see fit.
And will there be contract standards similar to ERC?
Yeah, I imagine so. Right now, there are these things called Polkadot standard proposals, so PSPs. And I've already seen a couple smart contract related ones there. So you can find those. There's a GitHub repo. I think it is Web3 Foundation /PSP or W3F/PSP, one of those two.
Okay. So how will Ink support standard contract libraries similar to Zeppelin so that developers do not have to repeat coding the existing implementations?
So really, this is more up to the community. There's already other projects out there like OpenBrush, which I think aims to be sort of like Zeppelin, but on Ink. There's nothing on the Ink side that's like locking us into doing this ourselves.
Okay. So is there a standard contract development environment tool in Ink, such as Truffle? And this question is from Chen Chao. Go ahead.
So it depends on what part of Truffle you're talking about. So I haven't used Truffle in a while. Maybe, I don't know if Alex, you have recently, but I think Truffle encompasses a lot of different things. Ink has some of them, like testing related, as far as, for instance, like forking a production chain and deploying your contracts at a given height, like we don't have that. And while we want to build some of that ourselves, again, I think this goes back to what does a developer community want to build? Like the Solidity core team didn't build these tools themselves, right? It was external parties that had this vision and idea for what would be useful.
So I think our like Truffle is cargo contract. It's a bit bare right now, so it's has mainly the main features like building, running tests, but it's designed to be for Rust developers to feel at home. But we will extend this in the future. It will certainly gain some features which you will know from Truffle. But if you are really looking for something which is more like Truffle, then you might be inclined to look into this a project from Patrick's lab. It's called Red Spot. This really like tries to be like, I think it tries to be Truffle for pilot contracts basically. So maybe you can look into that.
All right. Next question. Will there be redesign of Ink macros to make developers easier to locate bugs in contract code? When we are developing using Ink, sometimes it is hard to locate the bugs in contract. Usually we need to expand the code by using cargo expand to locate the bug to locate the bugs in contract code.
Yeah, so for this one, I'm curious as to what version of Ink you're running on. So the latest versions use some pretty clever procedural macros, and the errors are actually quite good. They're almost as if, or almost like the errors that come from the Rust compiler directly. So they point directly into the line of code that is an offender, and you should never really need to use cargo expand. If you do have an issue where you need to use cargo expand to figure out what's wrong, you should really open an issue on GitHub and let us know. But it shouldn't be the case. I don't know if Alex has anything else to add on that one.
I agree with you. So, of course, there's always room for improvement, but the idea is that the error messages won't require you to look into the generated code. But of course, please raise an issue if you see anything where we could improve. Of course.
All right, moving on. How do we interpret Gavin Wood's statement, WebAssembly is the future, EVM is right now? What kind of a new dApps can be expected having Wasm as the new contract environment?
Yeah, so this one's interesting. Like, I can't totally get into the mind of Gav, but how I sort of took it is that you can sort of think of it like, Apple's new ARM processors versus, current Intel processors. At the end of the day, they do the same job, but the newer processors are more efficient with certain things. In our case, WebAssembly is more efficient in terms of actual, how it actually runs, but also in terms of the developer tooling and environment community around it. So it'll just let us kind of move further quicker than the EVM. As far as the new paradigms that this could open up, as far as smart contracts are concerned, I don't think it opens anything new up. It is still the same sort of execution model of synchronous smart contracts. I think where it kind of does open other avenues up are putting nodes inside the browser. So for instance, we have a project here at Parity called Small Dot, which is a Substrate rewrite for the browser. And how it works is that we have this Rust code, it compiles down to WebAssembly, and you can run a light client directly in your browser. You never have to run a full node yourself. And you're really becoming part of this, peer-to-peer network without having, to spin up a cloud server somewhere. So I think those are the types of applications that WebAssembly can enable. What do you think, Alex?
Yeah, of course, I also cannot read Gavin's mind. So, I mean, if you say WebAssembly is the future, of course, if you look at smart contracts, right now there is no dominant WebAssembly smart contract platform. There are a lot of players who are looking into it, but there's none like Ethereum, which is the de facto standard. And so it's an emerging technology. And for smart contracts, like what it enables in the future, so the promise of WebAssembly is, of course, like faster execution, because you can compile it much easier to native code. This is rather difficult for the EVM to do. So at least to gain some efficiency from that. And I think if we can deliver on that promise, then we can drive gas costs way down. And this will, of course, then enable larger projects than we see today on EVM. You don't need to break it down that much, and it will just be easier to use. But I agree with Hernando. We chose intentionally a conservative approach. So it's like Ethereum, basically without its flaws.
Alrighty. The next question is, Will the Wasm contract performance differ when executing on a standalone chain or on parachains when it is compiled using ink? Currently, the Wasm file size compiled with ink seems big. Will the Wasm size be a problem for contract execution on parachains, as the parachains need to sync Wasm to the relay chain?
Yeah, so I'm gonna answer this briefly, but then pass it on to Alex because I think he's more qualified to answer this. So in short, yes, performance from a standalone chain and a parachain do differ. This is because when you're running on a parachain, you have to hand stuff off to the relay chain validators, and then they have to go ahead and run checks. You could see this just now with the block times, right? That's like an easy example to see or to show that there are performance differences. As for the contract size issue, there were some, or there are some differences in size between EVM contracts and Wasm-based contracts. But internally as a team, and even with some community members, we've been pushing really hard over the last month or two to get those down. And we've been making some really good progress there.
Yeah, so with regards to parachains, so if you're talking about parachains, it's basically a form of sharding. So we have multiple shards, and this is having smart contracts in a sharded environment is just a really, really hard problem. You can see that there's basically most of the smart contract chain start with having smart contract, and then okay, we will add sharding later, and none of them have added sharding, I think. And it's just because the fundamental problem with that, the validators, so the relay chain validators are stateless. They don't know the state of the parachain where the contracts and all of its states live. This is, of course, intentional. Otherwise, it wouldn't be really scaling or sharding at all. And therefore, yeah, they need to sync it to the parachain. And every time a validator executes a block, the parachain needs to send all the data it have used to the validator. So obviously, we want to get smart contract sizes as small as possible. We are working on that, and we are on a good trajectory. But there are still some things we are looking into how we can address this issue further. So first, on the parachain protocol level, there will be optimizations, of course. There is something which we call contextual execution, which will come up, which will unlock 6 block times on parachains, essentially, and allow also for bigger sizes of transmitted data from the parachains to the relay chain. And from the standpoint of contracts, we are looking into something which is called code localization, where we essentially are be able to only send the parts of the contracts which are executed to the validator, which will then we expect some very big gains from that, but it's obviously difficult to implement. Now this is on the roadmap, and you can even look into things like optimistic rollups. Where you then, I mean, it's a security trade-off. If a parachain is okay with trading away the property of, okay, we don't need our own validators, we rely on the relation and say, okay, we maybe have enough economic value to incentivize our own collators, which you call them in that case, they can get away with optimistic rollup, which is essentially like doing all the calculation only on their parachain and then just sending a signature from the collators which says, okay, this is all okay, please trust me. So this is something which chains can look into if they really want to like be some kind of very fast going chain with very fast block times, like a payment chain or something like that. So the TLDR is basically it will get better, and hopefully there will be no big performance difference anymore between relay chain and parachain standalone, but right now there is.
Okay, So how will Ink support cross-contract calls? Call another contract within the contract.
Yeah, right now we already have support for cross-contract calls. I think we have a couple examples. So for instance, the ERC 1155 example shows you how to do that. And then also a proxy example that we have a PR for. So go on GitHub, check through the code. There's a couple different ways to do this.
Okay, is there support for XCM/smart contract calling each other between two different parachains?
Not yet. It's something that we've started researching and that we're working on. It isn't quite as easy to implement as like calling contracts within the same chain. I think initially we're going to start off with a subset of XCM, so just being able to do things like transfers on different chains. Calling other smart contracts, I think, is a little further down the pipeline, but I think it's something that we should definitely strive to do. I don't know if you want to throw anything else in there, Alex.
No, I agree with you. We are looking into that. It's a high priority for us. It's just we are not there yet, but it's like our highest priority right now to get that in.
Okay. How do you ensure compatibility of calling Ink in Solidity or vice versa?
Yeah, so this one, at least from the Ink to Solidity side, I think in theory it's possible. I don't know if anybody's written a proof of concept for it, but you should be able to use these things called chain extensions to call from Ink into the runtime, and then call palette EVM to then call, some Solidity contract. One thing to keep an eye out for, though, is like you're going to need the Solidity contracts ABI to be able to format these calls correctly. So that's how you'll maintain compatibility. You need to keep track of this ABI. As for the other side, I'm not sure if palette EVM has a chain extension type thing implemented. But if they do, then it should be the same thing. Do you know anything about this, Alex?
Yeah, so the question is really much broader than it looks, I would say. The thing is, when you say calling Solidity, so Solidity is just a language. So are we talking about like having a EVM contract deployed on Palette EVM? Are we talking about a EVM contract deployed on original Ethereum, or are we talking about a Solidity contract compiled to WebAssembly with the Solang compiler? So the latter one is pretty easy. They can just interop seamlessly on the same chain because they use the same ABI. The second thing is what Hernando was talking about. It's having on the same chain, you're on the same chain, you have Palette EVM, you have Palette contracts, and it's rather easy to build things so they can interop. It is not implemented, but this is something that is totally possible, and we will be looking into that. And like, I think the thing what most people are interested in, which is also the hardest part, is calling like contracts on another chain. Like you have a Palette contracts on one chain, and then you want to call a EVM, like a Palette EVM contract on another parachain, or you even want to call a EVM contract on original Ethereum through a bridge. And both of that will be, or like maybe is already possible, because maybe you can just, I mean, all you need to do is like call an extrinsic on another parachain of the Palette EVM and encode the right arguments via XCM. So in XCM, there's this XCM transact instruction, which you can use to call extrinsics on another chain. And theoretically, you can write a chain extension for Palette contract, which then just emits the XCM transact thing, which will be then transmitted to another parachain, where it then will call a EVM contract. So, but all of this is possible, but none of it it's like implemented and easy to use right now. It's definitely on our roadmap, and we plan to have like general XCM support in Palette Contract, and then basically what users can do is just code that out in their contracts for now. It won't be like nice and easy to use, but if you really want to do that, I think you can do that soon.
Okay. Is there any tool or built-in functionalities to detect a vulnerability in smart contract? What are the ways to ensure the security of contracts in Ink?
So there are no built-in tools, although something that we've been looking into is, if you're familiar with Rust, you know this linter called Clippy, and Clippy gives you suggestions on how to write idiomatic Rust. And there's a project that was released earlier this year that lets you sort of define your own lints. So something that we would potentially want to do is define some sort of list of things that you should look out for, like anti-patterns in your smart contract, and just have cargo contract tell you about them when you build your contract. So in that way, we could probably mitigate, like, you know, some basic security vulnerabilities. Anything more complicated, like, you'll probably need to write custom tooling, sort of like what auditors do now in Solidity. They have custom scripts and sort of, yeah, like they do their own things to figure out if a security vulnerability exists. As far as, are there any tips on writing, say, smart contracts? I think since our model is basically the same as Ethereum, you can just follow good security practices from the Ethereum world. So checking before you modify something, updating balances before you actually execute. So, you know, set somebody's balance to 0 before you actually send out tokens. Be conscious of cross-contract calls and reentrancy, that sort of thing. Alex?
Yeah, so I think right from the start, just by choosing Rust and having all these, and having the Rust compiler and Clippy and so on, just by using a very security-oriented language, we are already, I think, in quite a good position. For example, we enable overflow checks by default, so you cannot have integer so you won't have integer overflows, which is really like right behind buffer overflows, which are not possible in Ink. Also not possible, which is like the second biggest class of bugs in programming. It's also not possible in Ink. I mean, you can like opt in to have that possible, but by default we don't allow it. And also we have, of course, all things Hernando says, but we also have support in palette contracts. So when you do a cross-contract call with palette contracts, by default, we don't allow reentrancy into the same contract, which also eliminates one huge class of bugs by a Solidity contract. So you actually need to opt in to have reentrancy enabled. So I think this is also something which contributes to like a better, a little bit higher baseline than Solidity had when they started.
All right. What general feedbacks are you getting from Ink's developer community so far?
Yeah, so I think the main thing I've heard is that Ink has done a really good job at just being Rust. And if you're a Rust developer, it is incredibly easy to get into. With that said, I think we do need more data points from people that are coming from the Ethereum world and just other community members. And that's where you guys come in. Like, we want, you know, part of this session is to motivate you to go try writing Ink contracts and give us feedback as to, you know, what you like, what you don't like, things we can improve, that sort of thing. But I think in general, the feedback's been pretty good.
Okay. Alex, anything to add in?
Yeah, so most of the feedback I noticed is like sitting in this ink channel, answering questions. And I think what comes up quite often is like people are confused about which version to use, because we had not a release candidate for some time, and we are juggling around these. So we hadn't a stable release for a long time and juggling around all these release candidates. And we will address that issue by putting out a stable Rust release soon, and then we'll just bump the major or minor version, so we can really tell people, okay, this is just use the latest version. It's okay. It's stable. We won't break your code without. So we will adhere to semantic versioning, and it will all be fine. I think that's an important thing to do.
Okay, sounds great. So that was the last question from the community. I saw a few questions popped up in the dialog box, so I'll just pick in the order. So first one, my question is if Ink smart contracts are composable just like the Solidity contracts? If yes, any examples? I think the question is how to call another deployed contract with Ink, and this question is from Fei Yang.
Yeah, so I kind of touched on that. Yes, they are sort of composable, like you can call other contracts. There are examples, there are small ones. I haven't seen any crazy complicated deployment just yet, but you can do it. You can do it.
Okay, another question is, I would like to know if there are performance metrics for Ink contract compared to the Solidity contract.
Not that I know of, not yet. I think part of it has been that there hasn't been a production WebAssembly based smart contracting chain available on which to do or collect these metrics. Yeah, Alex, do you have anything to say here?
Yeah, it again depends. When you say Solidity, what are you comparing there? I don't think it's a fair comparison to compare right now Ethereum to Ink, because Ethereum isn't sharded, so they don't have any issues with transmitting state. So the only like fair comparison would be to compile the output of Solang to the output of the Ink compiler, so essentially the Rust compiler. And I would say right now they're quite comparable, but we are having some. So the Ink team is right now working hard on getting the sizes down, because if you interpret code, not compile it, which is what currently happening on Palette EVM and Palette contracts, the execution speed is heavily dominated just by executed instructions. You cannot really like outsmart or out optimize that something. You need to get the code size down. And right now, Ink contracts are a bit larger and therefore execute slower. But I think in the future, there's a lot of potential for Ink to be faster than Solidity. If you just look at the language, Solidity is kind of constrained by their semantics. So they pass everything by value and they use a big word size. So right now we cannot, or we didn't yet deliver on performance improvements over Solidity, but I'm confident that in the long run, Ink will outperform Solidity.
Okay, if we don't have
There's one more question I saw that that I thought would be interesting to answer as well. Is it possible to switch from Wazney to Wasmer? And this one, so for those that aren't familiar, Wazney is a WASM interpreter that's being used to run these WebAssembly smart contracts on Substrate. And Wasmer is like a WebAssembly runtime environment or execution engine. I'm not sure what the right phrase for it is. And the answer, like in short, is no. Right now, we use Wazney to run contracts on chain. And we can't switch to Wasmer because Wasmer isn't an interpreter, although it could be. It has the right hooks to be an interpreter, but right now it's really like a just-in-time compiler. And we can't, we can't have that running as a WebAssembly blob on chain. I think we can and do use it as part of the Substrate like Wasm executor. So it runs the runtime, right? So remember there's like two places where we run Wasm, and it's fine to use Wasmer there because then everything gets compiled natively and you can execute, you can actually run, you can compile code and run it there. So Alex, do you want to add anything here?
Yeah, so right now we're using Wazney, and we have plans to switch to Wasmer. The problem, so there are two things why that didn't happen. So why that didn't happen until the end. So until now, the first reason is that it requires support of the parachain of the relay chain validator nodes. So they need to expose an API to the runtime so that we can use a Wasmer, which is a compiler, which is inherently platform dependent. Therefore, it cannot be deployed as part of the runtime. Therefore, it needs to be in the node, and therefore we need validators to install a node which have this in there. And like Polkadot 1.0 didn't have those APIs because we pushed it back to like a later point in time. But we're planning to bring them back, and then we can use other execution engines than Wazney. So this is the first reason. We need to like look into this API, maybe do a little refactoring, clean it up, and then bring it back. And the second part is that it is not completely clear that a compiler versus an interpreter is faster in all cases, because you need to keep in mind that we don't know which contracts are we compiling. So we need to, we cannot cache it. So we need to compile it every time it is ran. So then you have the compilation, which an interpreter doesn't have to do. And therefore, we need much faster execution later to recuperate some of those costs of the compilation. We are right now doing performance tests and looking into it. And we're seeing some promising results, but we couldn't prove that we get an improvement there from an end-to-end benchmark. But we have plans to replace Wazney one way or another, because Wazney is too slow. It was never meant as a high-performance execution engine, always like a secure, conservative starting point. So yes, maybe we switch to Wasmer, maybe we switch to something else, but eventually we will switch to something faster.
All right. Any other questions that you guys saw that you want to answer? No?
No.
Okay. All right. Okay. I think that's all we have for today. So thanks to Hernando and Alex for the wonderful sharing. We have came up with 4 people for contributing the awesome questions, and they are Yuan Jingchen, Chen Chao, Yang Fei, Guo Bing, and we'll contact you later and send you the prize from Polkadot. All right, so that's all we have for today. Thank you all for coming, and thanks Hernando and Alex again for joining us. We look forward to the next episode of the Substrate Saturday, and you might leave the conference.
Yeah, thanks so much for hosting us. This was a lot of fun.
Yeah.
Thank you.
Thanks for having us.
Have a good weekend.